According to Newton's law of gravity, the force F in newtons is a unit as well as a person. Well, newtons are a unit, Newton was a person. But the force F in newtons attracting two objects with masses m1 and m2, these masses measured in kilograms, that are a distance r in meters apart, is given by this formula. F is capital G, that's the gravitational constant, universal gravitational constant, times the masses over r squared. All we're being asked for is what are the units of G. So here's our equation, F G m1 m2 over r squared. So what are the units of everything else? We've got newtons, which is N, although if you know your physics, you'll know newtons is, what is newtons? So force is mass times acceleration, so mass kilograms times meters per second squared. So you could write newtons like this. The question's, I don't think, asking that. We're not assuming physics here. We're doing mathematical modeling. So we're just going to leave it as newtons. Although, if you want to stick around till the end, I'll change it into the SI base units. But no, so we got newtons on the one side. Those are the units of F here. And then what have we got? We've got G. We don't know the units of G, but the masses here, there's two masses that are both kilograms. So we can say they're kilograms squared. And r, this distance here, is in meters. So r squared gives meters squared. And now we can just rearrange. We multiply both sides by meters squared. So we had newtons. Multiply by meters squared. Divide by kilograms squared. It's like algebra, solving for an unknown. We're just solving for the unknown units of this universal gravitational constant. And here we go. The units, at least matching with what's expressed in the question, are meters squared newtons per kilogram squared. There we go. So those are the units of G. But as I was saying, right, so there it is. There's my final answer for the question as written. But if you know a little bit of physics, you know your SI units, your system international units, you can go further because newtons are kilograms. I'll do it over here. So we've got meters squared per kilogram squared, but the newtons are kilograms meters per second squared. So one of these kilograms here cancels out with one of these, and then we've got 3 meters. So we got meters cubed per kilogram seconds squared. Seconds squared there. So those would be in terms of the basic SI units. Meters cubed per kilogram seconds squared would be G. But this I would say the original is the official answer just because they gave us force in newtons. So we're not trying to change up all the units into basic stuff. But if you wanted to go further, there we go. There's also an acceptable answer.